Hello, everybody. So as Laurie mentioned, today we're going to go through kind of reality capture more with an engineering or a manufacturing focus to take a look at what we can use reality capture for, kind of more on the manufacturing side. As Laurie mentioned, I'm James, reality capture solution consultant. Just before we get too far with some of the naming, at RAND here at IMAGINiT, our kind of division that deals with photogrammetry, which deals with the Leica laser scanners, which deals with all that kind of stuff, is our reality capture division. What we're talking about now is an actual program from Epic Games called Reality Capture. Right? So there's a little bit of confusion sometimes with the naming. Obviously, they're very similar names, but we'll be taking a look mostly at that program today. So I've been in the AEC industry for over 20 years. Before I came to RAND, I'm actually up in Canada in one of our Canadian offices. So I worked for some of the bigger EPCs up here doing some engineering, inspection, design for all kinds of different stuff. I've got mostly a civil background, but also worked in architectural, structural, civil as well. So I'm a certified instructor with Autodesk for Civil 3D. I'm also certified in Unreal Engine, okay, and specialize, again, spend most of my time working with the Reality Capture program, the other Epic Games programs, Twinmotion and Unreal Engine, as well as all of the Leica hardware and software that we work with as well. Okay. A little bit of background here about IMAGINiT. Okay. If you're not familiar with us as a company, okay, we are Autodesk Platinum reseller. Okay. Again, over 40 years of experience, bunch of satisfied customer. We are Autodesk's largest service partner. We've got a large team of technical experts in the industry, right? So we've got kind of, again, two divisions. We've got our sales division, which sells you all the products, and then we've got a whole big group of technical experts that will help with running into any technical issues that you have, or developing workflows, or training, or that kind of stuff. Okay. We've also got Ascent as well, which is Autodesk's authorized publisher. Okay, I'll mention Ascent later. They've created a course for reality capture as well, so we'll talk about that a little bit later. Very quick webcast agenda. We're going to go over kind of just a quick overview of photogrammetry. Okay, we'll explain kind of what photogrammetry is and where it can be used, and again, kind of contrast that to using some of the terrestrial laser scanners or the SLAM devices, that kind of thing. We'll get into a little bit of industry uses, and then we'll focus more on where we can use photogrammetry specifically in manufacturing. So when we're talking photogrammetry, right? Actually, let me back up a minute. Okay, when we're talking about reality capture as a whole, okay, reality capture is really just the process of going out and capturing real world conditions. Right, that can be done something simple as tape measure. Right, in the old days, you just used to send a bunch of people out with a tape measure and grab dimensions, take notes, and then bring that back into the office. Okay. With further advancements in technology, we've got into the laser scanners, right? Both SLAM devices, which are mobile laser scanners, as well as the more terrestrial-based ones. Okay. And we can even do things with cameras. Right? And the cameras is going to get into then photogrammetry. So photogrammetry then is the science and technology of obtaining reliable information about physical objects and the environment through photos. So at its very heart, you go out with a camera, take a whole lot of photos of something, and then bring it into the software to then create a point cloud and then further create a mesh. Okay. The program we're talking about now, Reality Capture, is a photogrammetry program. You may have heard of some other photogrammetry programs. Pix4D is another big one. And those are the programs that will take all of your photos, okay, and then process those photos into point clouds. So starting with the 2D images, okay, RealityCapture is going to allow you to produce 2D and 3D representations of your sites and your models. So how does photogrammetry work? Well, it works on parallax. A parallax is like your eyes, right? You've got kind of two eyeballs, and using that displacement or the difference in the apparent position of an object, okay, viewed along those two different lines of sight, okay, it's measured by the angle or the semi-angle of inclination between those two lines, and where those two lines cross, then okay, you can start to get depths and start to place points so that that we can create that point cloud. Okay. Minimum parameters here required to take advantage kind of parallax, the position of the viewpoints kind of relative to each other, the orientation of the viewpoints, and common and unique features. Okay, so if we were going out and taking like measurements and creating a point cloud with a terrestrial-based laser scanner, there are some things that laser scanners are going to do a little bit better than obviously photogrammetry. Right? So if I've got a big blank wall, it doesn't matter that I have no unique features on that. I can still use a laser scanner and scan that wall and be able to get that point cloud relatively easily. You've got to be a little bit more cognizant of that big blank wall when we're working with photos. Okay, because the way that the program works is that it picks out those common and unique features, and then it ties them all together through various photographs to then create the points. Okay. The points that get created are those key points. So if I have, let's say, 5-10 photos, all showing the same unique object, okay, that object is going to become a key point. Okay, so that represents the same feature in overlapped images. So these overlapping images then are matched by capture time, by proximity, by image similarity. Okay, all of that kind of stuff comes together so that we can create these key points, which will then further go in and create our point cloud. Okay. One of the bigger questions we get all the time when we're talking about creating point clouds and creating with either the laser scanners or with photogrammetry is the concept of kind of how accurate everything is, right? The laser scanners from Leica or from Faro are measured, and we can get the accuracy, okay, from the manufacturers, right? They will tell us what the 3D accuracy of the point is based on their measurements. With photogrammetry, it's based on ground sampling distance. Okay, so the ground sampling distance is the distance between two adjacent pixel centers. Okay, so if you think of a camera, okay, and your camera, in your camera, you've got your sensor, right? Depending on how big that camera is, so let's say it's an 8 megapixel camera or a 32 megapixel camera, okay, your sensor size is going to have a number of pixels on. Okay, each of those pixels then has a size. If you project those pixels onto an object, okay, or onto the ground, they will then kind of get bigger and have a size that's on the ground, okay, or on the object. Okay, the distance between two adjacent pixels is going to be your ground sampling distance, okay, or your sampling distance if you're not doing the ground. Okay. That is going to correlate to how accurate your model is. Okay, so your ground sampling distance is going to be affected. Say we're using a drone. Okay, the ground sampling distance is going to be affected by the focal length of the camera. It's going to be affected by the height that the drone flies. It's going to be affected by how big the camera is, like the megapixels of that camera as well. Okay, and you can adjust what your ground sampling distance is by changing any of those factors. Right? If you get a bigger camera, the ground sampling distance is going to get smaller. If you fly higher or lower, it's going to affect the ground sampling distance. If you change the focal length, it's going to change the ground sampling distance. So as a rule of thumb, we're going to be able to get measurements of absolute location at an accuracy of kind of 1 to 3 times your ground sampling distance. Right? So if I have a ground sampling distance, again, these are different shots from drones. So in this case, we've got a ground sampling distance of about 1 inch, right? So 2.5 centimeters. The accuracy is anywhere between 1 and 3 times that ground sampling distance. So in a civil sense, that's usually fairly good for us. Right? Accuracy is going to be between 1 and 3 inches. Okay? It's actually 1 to 2 in the horizontal and about 1 to 3 in the vertical. So overall, it's kind of that 1 to 3 times the ground sampling distance for the accuracy of the model. Okay? So in something like this, like I said, we've got about 1 inch, which is going to give us kind of 1 to 3 inches accuracy for the entire model. In the bottom one here, we're going to have much more. So this is going to be about 10 inches. So our accuracy here is about 10 to 30 inches, right? Which may not be great. So in a civil sense, then, like I said, that accuracy is not bad. Okay, we can extrapolate that and kind of figure out accuracy as well if we're looking at, like I said, more of a manufacturing sense. If we're looking at taking photos of objects, right? If we have a large SLR camera, okay, or a DSLR that's like a 35 megapixel camera, okay, but we're only 6 inches or a foot from the object, okay, obviously we're going to get much more accurate data than we would from a drone. Okay, so even though we're using photos, we can still get really accurate data, especially for objects that we're using in let's say, for more of a manufacturing type environment. So if we take a look, there are trade-offs, right? So if we have a lower ground sampling distance or a lower distance, we're going to get higher accuracy, right? So if this number here is fairly small, right, the distance between pixels is 1 inch, okay, 1/2 an inch, 1/4 of an inch, right? We're going to get higher accuracy. Right? You're going to get more image detail. If we're talking about drones, you'll need to fly lower. If we're talking about a handheld camera, obviously you'll need to be closer to the object. Conversely, you're going to get way more data. Okay, we'll take a look at some examples later, and you'll see that with photogrammetry, it does take time to collect, right? And it takes a lot of photos. So if I want a higher accuracy, I can certainly do that, but I'm going to get much, much more data. That more data is going to translate into a lot more processing time. Higher GS or ground sampling distance, again, lower accuracy, right? Because I'm going to fly higher, I'm going to be further away, so I'm going to get lower accuracy, so I'm going to get less image detail, higher flight, but I've got less data. Okay, so there's kind of a trade-off between how much accuracy you want and how much data you're actually collecting, which again is going to translate into how big the point cloud is and how many photos you've got and how much processing time it's going to work through there. Okay. When we're looking at photogrammetry as well, okay, we're looking at a lot of overlap between the photos. Okay, so typically we want somewhere in the region of 70% overlap when we're looking at our photos, right? So that ensures that we get enough photos looking at the same key points to be able to more accurately place those key points. So the objective here then is to take clear, sharp images, correctly exposed, consistently lit, and that contain kind of as little noise as possible while sufficiently capturing all of the object. So in something like this antler, okay, even with this antler, we've got a lot of photos, and we can see where those photos were taken. Okay, so we've got a ring up at the top, we've got a ring down at the bottom, and then we've got a ring kind of going all around. And the result is that we get this antler here. So even with something as small as this antler, okay, and this has been processed, okay, it's had a mesh applied to it, it's got the textures all applied to it, and it's got a fairly accurate model here of this antler. I can see here again where those photos were placed. Okay, so we've got that ring at the top here, we've got that ring at the bottom, and then we've got another ring here for those photos. But even, as I was mentioning, even in something as small as this, we've still got 90 images, right? That's quite a lot of photos for something even fairly small. If we're outside, weather conditions and lighting are going to play a huge effect, or play a huge role in this, right? You typically, if we're taking objects outside, say it's a statue or anything else outside, we don't want bright sunlight. Okay? We want a nice overcast day that's not windy. Okay? So weather conditions, they're important when shooting outside. You don't want rain, you don't want snow, blustery winds that cause movement. Movement in the photographs, when we're talking about photogrammetry, is not good. Okay, we don't want bright sunny days, it can cause glare. Really, we want just a nice overcast day that's not giving any kind of bright light. With objects as well, we kind of want to avoid shiny objects. Okay. We can take shiny objects. Obviously, you can see here, there's some tricks that we can use. But to get the best detail, we don't want those reflections. We don't want that shiny. So generally, you want a rough and non-shiny stationary object, lots of kind of unique features. Okay. They can be done, but it's still going to be, like I said, it's going to be challenging to do that. So ideally, when creating photos for photogrammetry, we want heterogeneous, non-reflective, static, with simple geometry. Homogeneous, reflective, dynamic scenes with really complex geometry are going to cause issues. Okay. Can they be done? Yeah, they can. Again, there's some tricks you can use to get those type of scenes into the program and get some decent results. But they're just kind of things that we generally want to avoid. When you're taking photos, okay, with photogrammetry, there's quite a bit of things to be aware of. Again, it's best to kind of map it out. I always think it's kind of a time and place, right? Best tool for the job type scenario when we're talking about reality capture. Right? Photogrammetry is great for certain situations. Right? Things like using the drone for surveying, okay? Things like smaller objects like we're talking about with manufacturing. If we're doing interiors or exteriors of buildings, a laser scanner might be better. Again, you can do them, no problem. It's just going to take a lot more data and a lot more processing. Okay? Again, the way you take the photos is also important. Right? You can't just walk into a room, or you can't just go around an object and randomly take photos kind of where you want. Okay? There is a specific method for taking photos, which becomes more important when we're looking at photogrammetry instead of using laser scanners. Okay. So photogrammetry, though, can be used all kinds of different places. Right? Cultural heritage architecture. So if I've got things like statues or trains or any kind of cultural heritage, like I said, architecture. There may be instances that you can't get a laser scanner to that may be better used with photogrammetry. Right? Then I can certainly send a drone to get tops of buildings instead of using the laser scanner. This is a big one. This is kind of where photogrammetry started. Right? A lot more in the surveying, mapping areas. So it's been used for years and years in kind of the AEC BIM survey mapping kind of world to get those existing conditions, right? Stockpile volumes. As I said, it's really good for kind of sizes of plots that are maybe not big enough to get the fixed wing airplane with the LiDAR attached to it, but too big to have your terrestrial laser scanner go out. It's great for that. Right. Media and entertainment. This is getting big as well. Okay, so I can go in, I can scan people. Okay, I can scan locations with photogrammetry and then bring that into movies or into games. Epic with the combination of Quixel. They've got workflows online where you can use your camera and you can create an avatar of yourself. Right? They call them metahumans. I can go through and I can use RealityCapture if I want to go and take a whole bunch of photos of myself, and then I can bring them in, and then I can bring them in and actually put myself in a game or put myself in my scenes within Twinmotion or within Unreal Engine if I want to go and create myself. So we're seeing a lot of that in the media and entertainment space. Government agency as well. Right, so when I've been doing photogrammetry training before, we would get a lot of people from police departments. Okay, so after surveying, kind of police and the police departments were kind of the second biggest user group that would use photogrammetry for accident reconstruction. So instead of using a laser scanner, they would take a drone and fly it over the accident scene, okay, and then use all of the photos with the accident scene to do accident reconstruction. Okay, so again, it's picking up steam within those government agencies as well. Okay. And then we'll get into manufacturing. Okay, so there's a whole lot of places that we can use photogrammetry for manufacturing as well. Okay, starting off with prototyping. So for example, aftermarket car parts. Let's say that I'm wanting to create a bug deflector for a car. Okay, this is something, obviously the car shape's not going to change very much, so I want to create a prototype for it. Okay, I can go out, I can take my camera, I can go and take a whole bunch of photos of the front of my car, and then I can turn the front of the car into a point cloud or a mesh, bring it into my design software, and then design directly on that, on the front of that car that I've created. As we've seen, your accuracy, you can get quite accurate depending on which camera you're using, specs of the camera. And then I can use that to, as I said, I can use that to create those parts. Okay. 3D models of products for e-commerce. So again, I might have a product that I have, and I want to use that for e-commerce. I can take a whole bunch of photos of that, turn it into a model, okay, put it up on Sketchfab or bring it into Unreal. I could make it interactive. I could have people change the colors of it. Let's say I'm doing shoes, right? And I can take photos of the shoes and bring them in and have people change colors, have people change kind of other aspects of my object within my e-commerce. Okay. So that's one option that we can use, prototyping. This camera here, again, if I flip back to RealityCapture, I can take a look here, and I've got that camera. Again, it's got really good detail for that camera. Again, this is created by into a mesh, but again, it's got some really good detail in here that I can use if I need to like create replacement parts for it, or if something was broken and I need to create that. Okay. Lots of good options in here. This is again created as a mesh. Okay. Once I've got this mesh created, I can export it and take it into, I can either take the point cloud or the mesh into any of the other design softwares and use it from there. Okay. This camera again was done with about 72 images. Okay, so again, still a lot of data to create something even as small as this camera. Okay. So prototyping, again, good option for photogrammetry. Custom fit products, okay. Lots of opportunity here. Okay. The reason I've got kind of face mask and pool covers here, these are actual projects that we've been taking a look at in the past from kind of helping out customers. So one of them wanted to know whether we could take a face mask and customize it. And there are actually some companies doing that now. So we took a bunch of photos of one of the employees' heads, okay, and brought it in and created a model of that person's head. Okay, from there, you can actually go in and then use that head as reference and create a custom fitting mask that is custom to that person. It's similar with the pool covers. So I had a company contact me asking whether we could help with custom pool covers. Okay, their vision was to set up a website where their clients could submit photos or video of their pool, and then the company could create a custom fit pool cover for them. So RealityCapture will take video as well. So I can use video inputs. I can also use, obviously, photos. Okay, so I could go around and I can take a whole bunch of photos of my pool. Or if I wanted to make it a little bit easier, I could take video. Okay. Now, with video, what you've got to be careful of is the size. A 4K video works out to about right around an 8 megapixel camera. So you're not going to get a ton of accuracy, but the accuracy might be okay for creating that cover. If I wanted something more, obviously I need to go out with a bigger camera or a better camera. So that's another option, right? Creating custom pool covers. Okay, medical as well. Okay, things like prosthetic limbs. Okay, I can go and I can take photos of somebody's leg and or arm or wherever they need the prosthetic, and I can turn that then into a model, which then can have a prosthetic modeled around it. Okay. Custom interiors. Right? Let's say I'm doing the custom interior of a van or custom interior of an airplane or what have you. Okay, again, instead of maybe using a laser scanner in here to collect that, I could use photos. Okay, create that initial point cloud or mesh, and then bring that into my design software and design right off of that. Okay. Reverse engineering, okay, broken or missing parts. Okay. I may be able to, let's say I've got this broken cog or this broken, and it's going to take a couple of weeks then to get replaced. Right? If I have access to a printer or I can machine it myself, okay, maybe I've got a CNC, then what I could possibly do is bring that in, so use photogrammetry, Okay, bring that into my design software and replace the missing teeth digitally. Okay, from there, I could send it to CNC, or I could send it into my 3D printer and print the part in much less time than it would take to have that shipped. Okay, so again, that's going to come in handy for reverse engineering things, or for replacing broken or missing parts. So there's lots there of information and lots of different opportunities specifically for manufacturing, where we can start using things like laser scanning or reality capture, or more specifically working with reality capture the program to start capturing those conditions, and then bringing them into our design software to work with them. Okay. Getting started with reality capture as the program doesn't take very much. If you've got a camera, and everybody now has cameras on their cell phones, you can go in, you can start working with that to start creating point clouds. Reality Capture, the program, also has an app that you can use on your cell phone to make it easier to capture objects and start working with them. Okay. Again, you've got to be mindful of the size of the camera and the sensor within your cell phone, but it's a great starting place. Right? So you can get started for kind of very little to start creating these point clouds, creating these meshes, and then bringing them into your design software and working with them. Okay. Oh, this is what I was talking about here, Reality Scan. So you can create 3D models with your mobile device. Okay. So load it onto your phone and start creating directly with Reality Scan. Okay. If you don't want to use Reality Scan, again, you can, if you've got a digital camera, if you've got your phone video, you can also use it through there. Okay. So a couple more reality capture resources that we've got. Resources for reality capture, then including kind of tips and tricks, videos, blogs. We've got a few on the IMAGINiT website, resources website. Reality Capture itself, the product pages also has learning. Okay, so they've got some learning in there as well. They've got a bunch of tutorials on YouTube that you can get into as well. Okay. We've also got Ascent has been developing a course for reality capture. It'll be a 4-day course, I think, that gets into kind of all the nuts and bolts of reality capture itself, as well as a little bit of photogrammetry again, and how to take photos, what to be aware of when you're taking photos, and bringing that in and working with the program as well. Okay. So lots of different resources there for both the program as well as extra training there. So that's all I've got for you this afternoon. Any questions?